Let us move on to the next lecture, which is the 8th lecture on advanced level problems on impulse, collision and center of mass. However, in this lecture we shall do more problems on collision only. You know that collision can be of various types. They can be elastic or partly elastic or inelastic. They can take place in a straight line or on a plane or in space. Therefore, there is a large number of problems of various types on collision, and we have decided to invest enough time in solving them. A few words about the technique of solving problems on collision. The definition of collision taught us earlier that's an event in which two or more particles come together for a short time and exert large forces on each other. Because of the impulsive nature of the force of interaction between colliding particles, even though other forces like gravity or friction are present, you can almost always apply momentum conservation principle in problems on collision. In addition to that, if it's elastic collision, kinetic energy for the system remains conserved. If not, we can go for the definition of restitution coefficient to get a relation between the velocities after and velocities before a collision of the colliding particles. Keeping this in mind, let us go for the next set of problems. It will be of moderate difficulty, hence I shall mark them with 2 dots here. Although they have not given any figure in the question, it's a good idea if we could draw a figure to illustrate the problem situation and could keep on developing it as we get important step result in course of calculation. So here is the horizontal surface shown, and suppose the particle is projected at an angle from this point on this surface. This is the velocity initial, they have called it u, and that one is making an angle of theta with the horizontal. We shall choose a coordinate system conveniently whose origin coincides with the point of projection. Plus x axis points horizontally rightwards and plus y axis points vertically upwards. So here is the origin. This is the plus x axis, this is the plus y axis, and suppose the particle is launched at time t is equal to 0. This is the point of projection, which is also the origin of my coordinate system. Now you have learned a particle thrown like this travels in a parabolic trajectory and hits the ground again after some time. So this is the point where the first impact between the particle and the horizontal surface happens. But we shall go to that place later. Let us refer to this first figure and resolve this initial velocity vector u into its 2 components. We have got a horizontal component pointing to the right and a vertical component pointing upwards. And this component is of course u cos theta, and the vertical component is u sin theta. So let me write it here as well. I am writing down at the time of projection, we get the initial velocity vector of the particle, if I could call it u. It has got an x component, ux is equal to u cos theta, and a y component, uy is equal to u sin theta. Now what happens during the flight? The motion happens only under the force of gravity, and therefore this x component of velocity doesn't change at any point during the flight. So when the particle reaches here, before the first impact, the velocity component along the x-axis remains the same, that is equal to u cos theta. But the vertical component is influenced by the free fall acceleration g, therefore it becomes 0 at the highest point, then becomes downward, and at this point before the impact, the y component of velocity becomes equal to u sin theta in magnitude. The direction becomes vertically downwards. So keeping this in mind, let me write down a few informations regarding the first impact now. We are into the first impact between the particle and this horizontal floor, and suppose the time of flight between the projection and the first impact that time I'm taking to be t is equal to t1. So suppose just before the first impact, we call the velocity vector of the particle as v. This v has got two components. One is vx. As we just now said, this vx remains equal to ux throughout the flight. So I'm writing vx is equal to ux is equal to u cos theta only. And the y component of this velocity vy, just before this first impact, that is equal to minus uy. This is minus u sine theta.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.